Okay, so 7.2, volume, the disk method. Our learning goals are to find the volume of a solid of revolution using the disk method, the washer method, and known with cross section. We will both mostly be doing disk method and washer method. Okay, so we have a solid revolved. If you look at all of these shapes, they have a center, and it is, I want to say symmetrical, but it's the same. You could have a cross section and just rotate it and get the object. Does that make sense? Like the same shape. Like here with this, if I cut it right here, so that would look like and if I took it and rotated it about this axis, I would get that shape. Do you see that now, what I'm saying?
Oh, yeah.
Okay. So if I took this and rotated it, I would get this. So the cone, I should have left it the right way. But the cone, if I just took and go something like that one line, if I took it and rotated it infinitely many times around, it would be that cone. Does that make sense now?
Yes.
Okay. So we can find the volume of these things. Can you imagine trying to find the volume of this cone?
No, but it sounds like I'm going to.
You are going to.
How do I know?
Okay, so volume equals the area of the disk times the width of the disk. So we have pi, because it is what kind of an object?
Around.
It's a round object, so the area of a disk would be the area of a circle, correct?
Yes.
Okay, so we have pi r squared times w. A capital R is the radius of the disk and width of the disk.
Or does the W equal width of the disk?
Say that again.
Well, R equals radius of the disk, and it has and W equals width of the disk. So like R.
Oh, okay, yeah. Say R is the radius of the disk.
Okay, that's what I was.
Okay, sorry. Okay, so we have the change in volume, because this isn't going to always be the same also. So delta means change. So change of V equals pi capital R squared change in X. So if your width is changing as it rotates, because not all of those were constant.
Yes.
Okay, so I have the volume of a solid is approximately the sum from 1 to n of pi times r of x sub I squared delta x, or change of x. And then your pi is a constant, so it can go out front. So we have pi, the sum from I equals 1 to n of r of x sub I squared times delta x. So, but we also know that the summation can turn into an integral, yes?
Oh, yes.
Because I don't want to do the limit method, do you? No. So we would have pi a to b of r of x sub I squared dx. I ran out of room. So you don't need to write this down. This is kind of the process we just went through. So we just want to think about it. So I have this shape right here. This is a cross section, and it's filled in, so it's solid, of this shape. Can you see that?
Yeah.
Okay. And then, now we talked about before, like when we had a curve, when we wanted the area under this curve, we had all these little rectangles, right?
Yeah.
Okay. So it's the same thing, same kind of concept. Could I make the shape into a bunch of little not rectangles, but circles, and add them all up? Like add cylinders, not circles. Sorry. Circles don't have volumes.
Yeah.
So could I make them into all these cylinders and then adding them all up?
According to that picture.
According to that picture. But this shape is not rigid lines. It's nice smooth curves. And nice smooth curves, you would use the integration process to evaluate an infinite number of those. Correct? That's what we've been doing. Yes. So this just goes through the progression here. So there's two ways we can do this. We can rotate around a horizontal axis, or we could rotate around the vertical axis. Now, look careful, please. Horizontal is the x-axis, yes? Yes, because this is the x-axis. Oh, that's an eraser. This is the x-axis, correct? So everything is in terms of what? X. But vertical is rotating around what axis? The y-axis. So everything is in terms of y. But is it the same thing? Like, is it the same equation? That's not very confident. Look at the equations. Are they exactly the same?
Well, besides the x and the y.
The x and the y, and then the a and the b, and the a and the b, and the c and the d. That just is. If it is rotating vertically, you need y values for your a and b, correct? If it's horizontally, you need x values.
So that's how you know.
So I want you to notice the change of y and the change of x is the width of that rectangular shape. Do you see that? Okay. And r of x is the height when it's horizontal, or the length when it is vertical. Right here, the r of x is the height of the rectangle if it is horizontal, and it's the width. Well, in that case, it would be r of y, correct? Now, that to me is counterintuitive, because anything that this on the y, that's a horizontal. That rectangular is laying horizontally, and my brain wants to make that of r of x because it's laying horizontally. But it's r of y because it's being rotated around what axis? The y-axis. I don't know why I was just coloring in that box. I felt the need. Okay, we good? For now. Okay, so find the volume of a solid formed by revolving the region bounded by the graph of f of x equals the square root of sine of x. And the x-axis. I think I might have a picture. There we go. From 0 to pi, about the x-axis. So we're rotating, so you need to be drawing pictures. So, and I'm going to go back, and we're going to draw this picture without, okay? So we're rotating it about what axis? The x, right? So, and we're going from 0 to pi. So what do we know sine looks like from 0 to pi? It starts 0 and then goes down to, at pi it's back down to 0, right? So we 0 and we have pi. So, and then we are rotating it. The easy way to show yourself how it's rotating is you just go like this. And it kind of looks like it's three-dimensional.
Very three-dimensional.
The arrow, nothing else. Okay, so then here's the picture that they had. Same picture we had, yes?
Yeah.
Okay, so our change of x is on the bottom. This is our change of x. And our r of x is the height of that rectangle. Okay. So if you remember right, the formula is the integral from a to b. Oh, I forgot my pi, didn't I? Pi, the integral from a to b of r, so x sub I squared dx. Yes?
Yeah.
Okay, so our volume equals pi, the integral. Well, what's my a and what's my b? What to what? 0 to pi. And then this is just the function squared.
Like the sine, like the square root of sine x.
Yes, so we have the square root of sine of x squared dx. So how are we gonna, what are we gonna do before we integrate that?
Square it, make it just sine of x.
Okay, so we just now have the integral from 0 to pi of sine of x. Dx. Okay, well, what's the integral of the sine of x?
Cosine x.
Is it negative cosine x?
Can never remember.
Why don't you look?
She's all over here. Probably is.
Well, because the derivative of cosine is negative sine.
So sine would be negative cosine.
So sine would be negative cosine. So I have negative pi.
Why'd you bring the negative up there just for fun, please?
Oh, because, yeah, I can. I can leave it in. I'll leave it in because you probably would. So you have pi of negative cosine of x from 0 to pi. Yes?
Yeah.
So I have pi, and I plug it in. So b minus a, right? So negative the cosine of pi. What's the cosine of pi?
Negative 1.
So negative 1 is a
Positive 1.
positive 1. And negative the cosine at 0
Is 1. So negative 1. So 1 minus 1.
oh, but it's minus 1.
Yeah.
Okay, so it is,
Why is that minus?
because the integral is b minus a. Yes?
Well, yeah.
It's f of b minus f of a. So it's, when I put in 0, it's minus 1, but it's a negative first. So it'd just be 2 pi. And do we have any units?
2 pi. Or 2 pi is the same.
It's volume, so we should have some units, right? They
It's
didn't give us any units?
There's no units, unless plane region is what you want to make your units.
No. Like inches, centimeter, you know, like,
Sorry, that's just being smarty.
oh, okay. So I just put it in there.
That's all you have to do.
Yep, that's it.
It's not that bad.
Okay, so find the volume of the solid form by revolving the region bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. Okay, so we're not sitting on the x-axis, we're sitting at g of x equals 1. Yes?
Yes.
So that means we moved everything up 1. Okay?
Do we need anything with the
And then we're about the line y equals 1.
Is that just telling us which way it's
Oh, yeah.
going?
Okay, so this is really weird because you have g of x and it's about this line. That's just the equation of the line. Right?
So the g of x is not.
No, we don't really need anything with that.
So will it make a difference to the formula, like if it's, up 1 or down 5?
Oh, yeah. Sorry. We need to take an account. Thank you for asking me that question because you're right. Because it does do something. It doesn't do like, so when this happens, when we have this moving it up here and we're not on the x-axis, we have to take r of x equals f of x minus g of x. Now, if it's on the x-axis, g of x is 0, yes?
Yes.
So when I subtract it, does it do anything? No.
It just stays the same.
Right. So for here, f of x is 2 minus x squared
minus 1.
minus 1. So I'm pretty sure that is 1 minus x squared.
Yeah.
Okay, so that's my r. Okay, and why did we have to do that again? Because we brought it what?
Off the x.
We brought it off.
So it's the same if it's off like the y.
Right. You would do the same. But when I didn't do it when it was on the x-axis because that would be minus 0, which wouldn't change
It
it.
wouldn't make any difference.
Right. Okay, so now I have the volume equals pi, the integral, well, from what to what?
Negative 1 to 1.
Negative 1 to 1 of r sub x, which is now
1 minus x squared.
quantity squared dx. I don't know why I didn't put curvy brackets. But now I need to square that, don't I? You FOIL it. So pi of the integral from negative 1 to 1. So we'd have 1 minus 2x squared plus x to the 4th. Right? And now I just integrate. So pi x
X to the third. It'll be
2 over 3. X to the 3rd plus
So the fourth must be 1/5.
1/5 x to the
Or
5th.
Sorry, I do them backwards.
Okay. That's fine.
So then you just plug.
So we just plug everything in.
Wait, and then with the
So we're going to have 1 minus 2/3.
So you start with the upper one?
Yeah,
Okay.
b minus a. Plus 1/5 minus negative 1 plus 2/3 minus 1/5. So that would be plus 1
Plus 1, so
minus 2/3.
plus 2/3. Plus everything else, so it's just 2 pi, isn't it?
No, I don't think. Well, I got to get common denominators, right? So I would have 2 minus 4/3 plus 2/5, right? Okay, so common denominator has to be 15.
Wait, but when you combine, how'd you get minus 4/3?
Because I have negative 2/3 and negative 2/3. Because I had to distribute that negative that was here.
But that made it positive.
Yeah, because it was negative.
And negative
Wait.
two-thirds
Wait.
is 0.
I need to do that again because I think it was supposed to be negative. Okay. So minus negative 1 plus 2/3 minus 1/5. Yeah, so that made this positive, this negative, this positive. So we have negative 2/3 and negative 2/3, so I had negative 4/3. So then I have 30 minus 20 plus 6. We're almost done here.
Yeah, I'm just kidding.
And then to be 10, 16. So 16 pi over 15.
If you weren't freaky fast, yeah. Yeah, that's 16.
Okay. And that's it for today.